Today we're going to talk about some developments on getting an X to the edge to run on embedded devices that have been happening for the past 10 months or so. And we're going to both talk about things that are already possible. We're going to see some of those, and then talk about next steps for the ecosystem in that direction. So this talks about bringing an X to the edge, and in that we are now able to harness dormant computing power that we already have in our homes. And most importantly, we're also expanding the frontiers of what Elixir can do through an X. And before I go too far ahead in this talk, I'm going to talk about a bit about myself. I'm Paulo Valente. I work as a senior software engineer at Dockyard. I'm co-maintainer of the NX ecosystem with Jose, Sean, and Jonathan. And I want to highlight that most of the work that's being presented here was developed during my work hours at Dockyard. And that's one of the biggest contributions that I think I'm able to bring to the ecosystem, Elixir ecosystem. And all of the code that I'm going to show here is present at the Elixir NX organization on GitHub in the NX IREE GitHub repository. So before all of this work started, we were already able to run an X on CPUs in general and CUDA GPUs. And now we have a few other devices that we're looking into. So we're now able to run on Metal, which is the framework for Mac GPUs. Via LiveView Native, we can also run on iOS. And those other devices that are marked in yellow, Android, ROCm, Web GPU, those are theoretically already possible, but pending some developments. ROCm and Web GPU, we basically need to validate that those already work. And Android is just pending LiveView Native actually being brought to Android as well. And Nerves is a work in progress that should be releasing soon. And what do I mean by iOS? This video is a recording of my iPad screen. And it's just some function that adds noise to the camera images that are being captured. And that slider is controlling the amount of noise. And that's running fully on the iPad. I want to highlight that there's no data being transferred between the client and the server. So after we load the code onto the iPad, it's just an X running on the iPad via LiveView Native. And to understand the example that's being shown here, we're going to through a few different steps because we need to go from Elixir code down to an X-define expression, which is an intermediate representation that we have in an X, down to MLIR, which is another intermediate representation that's defined outside of an X. And finally, we get the machine code that can be loaded onto the device. So the process that was being applied to the image is basically this, where we pass in a random seed to a random number generator, and that generates the noise that then gets kind of added with some weight to the image that was captured from the camera. And then that's the output that we show on the right side of that video. And to talk about the first step, NX provides a set of macros, which are defn, defnp, deftransform, and deftransformp. And all of those are going to be outputting a representation that we call the NX-defn expression. It's a nested struct that contains a symbolic representation of a computation. of an NX computation. So you have a function, and this, up until now, it's regular Elixir code that's calling NX, then NX-defined modules and functions. And this is exactly the function that's being applied on the iPad. And after we compile that, we get in an NX-defined expression. On the right side, you have like almost the full expression that that function generates. So you can see that there's lots of expansion happening as well. We have lots of more lines of code in that one than the Elixir code, and that's going to be a trend here. If every time that we lower from one level to another, we get more lines of code showing up. But basically, you can think of the defined expression as a different sort of listing for the same algorithm that you wrote in Elixir. And then we lower it down to MLIR, and I just can't show the whole module because it's huge. I'm going to show a little bit so you can see how MLIR looks like. But MLIR is a mid-level intermediate representation that's still hardware independent, so it doesn't know where it's going to run yet. And the way we get an NX-defined expression down to MLIR is via the EXLA library that's provided with NX. And that's also the way that we mainly use to run on CUDA devices up until now as well. So this is kind of like what MLIR looks like, and especially I want to highlight that we run on the stable EGLO dialect, because MLIR has lots of dialects. And you can see that it's kind of similar to what a defined expression looks like, but because we're one level lower, it has fewer abstractions, and then it has more lines of code for representing the same stuff. But in the end, it's something that representing a computation that takes in this case, 3 tensors, and outputs a new tensor. Tensor here being a list of numbers, basically. We're representing with width, height, and channels. Channels being red, green, blue, and alpha channel for an image. And then to lower MLIR code down to machine code, we can achieve that either via XLA or IREE. XLA is the main library that powers the XLA, and that's how things have been done so far in the NX world. And we're still using that in this workflow, but we're stopping at the MLIR step, which is still done via bindings that come with the XLA library. But then there's this other library, which is the IREE runtime. It's an intermediate representation execution environment that's specialized in compiling MLIR down to machine code, and that's lots of targets. So that's where those web GPU and ROCm targets come from, for instance. For Nerves, we're going to use RISC-V targets for RISC-V enabled Nerves devices. And one thing that's important here is that NX generally has a JIT compilation workflow where you compile and run things right after compiling. But IREE works with ahead of time compilation, AOT. So we're taking advantage of that split compiler and runtime architecture because the compiler is a lot bigger than the runtime. And the runtime is small enough that we can embed that easily onto devices, the device that we want to run things on. So this is kind of the rest of the code that takes that function in and lowers it down to exactly the device that we want to run. And this is done in a more generic way because it's part of some code that I have in a LiveView. So you'll see that there's lots of, so if we find a target, then we use that. If not, we fall back to the CPU and whatnot. But in the end, it's just a way for us to tell the IREE compiler that we want to compile our MLIR code down to something that can run on, in this case, on the iOS Metal GPU. And it follows a similar interface to what we have in the defn compiler in NX, where we have to pass the templates for what the inputs actually look like, so that the code can know what to expect. And that's what we're doing like at the bottom there. And then we get the bytecode that we're going to send down to the iPad via LiveView Native. So, talk about that. LiveView Native provides, at its core, a way for us to communicate, to add a communication layer between iOS devices, in the case of the SwiftUI client, and a server that's running a regular LiveView application. So with LiveView Native, we can add the capabilities to react to server commands and send data back to the server as well. And in this case, we're doing it in such a way that as soon as our client connects to the server, the client also sends an event with what capabilities it has. So it's basically the iPad declaring, OK, I have a GPU. You can use that if you want. And then the server will compile the code based on that information. That's basically what was going on the top of this slide. And after compiling the code based on that information, the code gets sent to the client. And we're going to talk about that in a little bit. And then after the code gets sent to the client, no more data needs to travel through between the client and the server. All data can be passed through internally between different components in the LiveView component that I created, LiveView Native component. So this is like a general overview of what a SwiftUI component that can do that looks like. And that's like a small section of the file, just with the layout of, OK, let's have an input image, the output image being displayed and whatnot, the slider. And there are lots of hooks such that we can, whenever something changes, let's say, for instance, the server wants to process a different height or width for the image, or it wants to process on a different device, or it's a different function that the server wants to run, then the LiveView Native client can react to that and kind of cancel everything that it's doing and start the workflow again, but with the new code that's being received. And that's another section of the code. That's the main function that runs the processing. So it receives the image that was captured from the camera on that given time step, and then does lots of unpacking, data formatting, such that we can finally call this function, the NX-IREE image call, which is ultimately a C function that I'm calling from Swift. And that receives the data for the image, plus the random seed, the noise amount, and the actual code that the server sent to the iPad. And the result here is the data for the output image in the same order that it received for the input image. And on the server side, you just need to add that to your template to get everything working, like that whole demo working just needs that on your template. So the signature, bytecode, device, height, width are now attributes that are observed by the LiveView Native component. So if any one of those changes, we restart the workflow and can maybe even run a different filter on the image or process the image in a different proportion of height and width. And yeah, so that's what I meant by running NX on iOS. It's really running on iOS. It's calling C code from Swift, but in the end, it's using the iPad hardware only. It's not sending data back to the server as we would have had to do before all of this work was done. And another use case that we have that I want to mention, because that was the previous demo that I had, is that because we can kind of declare the capabilities of a given device upon mounting, and because the device can receive data and send data back to the server, we can actually register iOS devices or LiveView Native clients, in general, Nerves devices. We can, as soon as those can run NX in some way, we can register them via LiveView, via presence, to basically enable them to be runners for your NX code. So instead of just load balancing between the devices that the computer has available on that specific node, you can also use those clients as devices that run your code. For instance, in an NX serving that's receiving client requests. And that uses basically the same workflow that we're talking about here, but instead of getting the data from the device and outputting it back to the device, it's getting the data from the server and sending it back to the server. And as I've hinted at, the next step here is to get Nerve support, and that's pretty far along in the sense that the workflow for getting that to work is mostly figured out. I just didn't have enough time to develop that yet. And Android support requires further development of LiveView Native, but as soon as LiveView Native can run on Android, then we'll also have the same capabilities we have on iOS without having to sweat too much about that. And other devices that IREE runtime supports are basically just pending validation on our end. David Bernheisel was talking to me about validating the RockCam environment. We can also validate web GPU deployment, but that's still pending validation. And before I sign off, I really want to thank the NX team for all of the discussions and features that led up to this point. The LiveView Native and Dockyard team for the direct support, both in the features and the talk. Probably I wouldn't be presenting this here without them. And also I want to highlight the help that the IREE team has given throughout the whole process, really. Without having the ability to talk to them via Discord, I probably wouldn't have figured out how to use their library properly, such that we can harness Metal from NX right now and run NX on iOS and all of the things that we've been discussing so far. And thank you for your presence here as well.